Okay, so we're on to another puzzle here. And if I look at the left side of the equation here, 2x plus 1 squared equals 8. The left side, because there's a squared here, that means it is a quadratic family. That is a key to being a quadratic family. And so if we were going to find the solution to this scenario with Desmos, let's do it graphically. So if I'm going to go to my graph, y equals 2x minus 1 power 2, and y equals 8. Let me make sure I typed it in correctly. Oh, it's x plus 1. All right, so, and it equals 8. So the first part is the orange graph, and I get a nice parabola here. The second part is y equals 8, and what you'll notice is there are 2 points of intersection. Again, I'm looking for the x value, so that's going to be x is minus 3 and 1. So I'm going to take a quick snapshot of this. Paste it over here so we can see it. So now I have my graph. I can talk about the solution. And so I could draw a quick sketch of this, and then I clearly say x is equal to 1 and x is equal to minus 3 is my solution. And this is a sketch with solution. And to make it even better, I should say y is equal to 2x plus 1 squared. And this is y is equal to 8. And so when you do a graphic solution, label the graphs. I should see your graphing window, and I put my solutions on there. Now, I should also do a sketch. I could do this scenario here as such, but since I'm doing it electronically, I can just do it as such. So now, if I look at the key features of this red graph here, it says the gradient is not relevant. The reason why it's not relevant is because gradient refers to what we call the slope. There is a rise and a run, and a rise and a run. And these rises and runs are always consistent. If I look here, let's say, I could rise up 1 and 3 and over 1. Now, if I'm going to go to the next point, it's going to be here. I'm going to rise up 5 or 6, and I go over 1. And so it's not consistent. It is a curve. And so there is no gradient when you're talking about a parabola here. Parabola is another word for quadratic. Quadratic refers to the equation. Parabola refers to this particular graph here. So then if I want to do, so you can answer this in your own words now. The y-intercept in this case, well, if I look at my y-intercept, I can see that it is 2 from the graph. And the x-intercept, if I look here carefully, I can see that it is, this is negative 2, so that is negative 1, 0. And I can get that straight from the graph. Now, if I'm going to solve this particular problem algebraically, I'm going to do it 2 different methods. Method 1 is what we call PEMDAS backwards. Okay, and so if I take my equation 2x plus 1 squared equals 8, I'm going to undo all the orders of operation. Okay, which means I'm going to divide by 2 both sides. So x plus 1 squared is equal to 4. Then I'm going to come along and I'm going to square root this. But when I take a square root, don't forget plus or minus. And so it's x plus 1 is equal to plus or minus square root of 4 is 2. And so now I have 2 answers. If I subtract 1, I get negative 1 plus or minus 2. Well, negative 1 plus 2, if I do the one calculation, is 1. If I do the other calculation, I get negative 3. And if I look up here, that's exactly what I get from my graph, 1 and negative 3. If I choose to solve the problem another way, 2x plus 1 squared equals 8, the other way I could do is I could expand this whole side out. So it's 2x plus 1 times x plus 1 is equal to 8. And then I'm going to multiply this out, expand it out. X times x is x squared. X is x. 1 times x is another x. 1 times 1 is 1, equal to 8. So I get 2x squared plus 2x plus 1 is 8. And then I can distribute this in. So it's 2x squared plus 4x plus 2 is equal to 8. If I subtract the 8 over, so I get one side equal to 0, plus 4x minus 6 is equal to 0. And then I have to what we call factor it. I'm going to pull out my common factor first, 2. And I get x squared plus 2x minus 3 equals 0. And then I ask myself the magic question, if you remember that from last year. These are both x's. What two numbers multiply to get negative 3, and then add to get a positive 2? Well, if I do a positive 3 and a negative 1, that will work. And then I know that x minus 1 equals 0 by the null factor law, and x plus 3 equals 0. And so then x equals 1 and x equals minus 3, which again is what we got up above. But the important thing I want you to recognize is look at all the steps involved in this particular method, the expanding method, versus PEMDAS backwards. This method here, if it's set up in this particular format, is by far superior algebraically. This works, but it's a lot of work. All right, so if I verify my solutions, I look here at my graph, I get 1 and negative 3, I got 1 and negative 3, and I got 1 and negative 3. Therefore, I have verified. I am golden. So there's another type of puzzle that you get when you're in this class now.